Okay, hello everybody, and welcome to a new session on function-based sizing. The objective for today is going to be to, first of all, walk you through the process of identifying the function-based sizing inputs and how to rate those inputs according to the complexity. And then once we've covered that, we're going to be walking through an example on how to apply those concepts to a real example. Okay, so I'm going to go ahead and share my desktop, go over the presentation. Okay, so let's start by, at a high level, defining that there are going to be two types of inputs for function-based sizing. We're going to have data functions and transaction functions. The data functions represent the storage means that the application has to store information. And those data storages could be internal to the application, or they could also be external to the application, okay? And then the transaction functions are going to be the inputs, outputs, and queries that move information from outside the application into the application. So those transactions either bring information from the users to the application or present information from the application to the users, okay? So first of all, we're going to be talking about the data functions, okay? So we know that we're going to have two types of data functions. We're going to have internal logical files, and the internal logical files are basically a group of data that is maintained by the application. So that means that an internal logical file is internal to the application, is the data that the application holds and maintains, okay? So the subcategories that we can have of internal logical files are going to be application data groups, or data tables, or database tables, okay? So these subcategories are just an additional classification of an internal logical file, okay? But the counting rules and the complexity ratings are going to be the same for these three subcategories. In other words, doesn't matter which subcategory you select for the internal logical file, you're always going to count it the same, and it's going to have the same contribution to the estimate. So the subcategory is something that is not relevant for estimation purposes. It's just an additional classification of the ILF, of the internal logical file, for documentation purposes, or you know, to do a more precise classification of the data. Okay. In a similar way, an external interface file, it's a group of data that is referenced by the application, but it's not maintained by the application. So it's data that resides externally to the application, okay? But it's not maintained by the application where counting is maintained by a different application. And as well, you can have subcategories of external interface files. You can have reference data, fixed messages, or shared data files. But again, the subcategories are just an additional classification. They are not going to have any impact on the count or the estimation. Okay, so a little bit more here on internal logical files. Remember, an internal logical file is data that is maintained by the application. So if we have a screen like this that collects information from the user, Okay, so the user comes here and specifies values for all these fields. Okay, description, analyst, element type, platform knowledge base, application acquisition method, development method, development standard, and class. So when that information is collected from the user, it's going to be stored in a data file. It's going to be stored in an ILF inside the application, okay? And that ILF, in this example, is going to be the work element information, okay? So this is an ILF because it's data that is maintained by the application, okay? It's maintained within the application, and it's recognizable by the user. So the user knows that this information is going to be stored internally to the application, okay? The user knows and understands that there is an internal logical file that holds the work element information. So when the work element information is collected in SEER, for example, gets stored in an ILF, okay? More examples here. You know, we collect information from the users. That information flows into the application and it's stored internally to the application in an internal logical file. Okay, so it's data maintained by the application. One more example here, the database that holds your contacts information in your smartphone. So the contacts information is collected from the user, and when you press on the save button, that information gets stored internally in an internal logical file that's called contacts information or something like that. And as well, the information in that internal logical file can be used to, it can be presented to the user in reports. You know, you can present a list of your contacts. So that information is stored internally to the application. Now, the external interface files, on the other hand, are data that is used by the application, but is external to the application, okay? So a good example of this would be the benchmark application in SEER, for example. So the benchmark application is a feature of SEER that allows you to plot your estimate and compare that estimate with all the repository of actuals in the ISPAC database, okay? So all these points, all these dots here that you're seeing on this chart correspond to projects, historical projects. Those historical projects are stored in the SEER repository database, okay? But the SEER repository database, it's maintained by another application, okay? It's maintained by another application which is called the Historical Database Administrator. It's not maintained by SEER. It's referenced by SEER, but it's maintained by the Historical Database Administrator. So this data is referenced by the application we're counting. In this case, we're counting SEER, okay? In this example, we're counting SEER. So SEER is referencing the SEER repository database, which is not maintained by SEER. It's maintained entirely within the application boundary of a different application, okay? So that means that the SEER repository database is an external interface file for SEER, but it has to be maintained by another application, and therefore it is an internal logical file for that other application, okay? So here's another example. You know how you can assign ringtones and alerts to different contacts. So inside the contacts management application, we have the contacts ILF that holds all the contacts information, but this contacts management application could also reference the ringtones and alerts database, where you have all the different ringtones installed in your phone. So the ringtones and alerts database is an external interface file to the context management. Again, it resides externally to the application and are maintained by a different application. Okay. A couple of counting rules here for data functions, and again, this applies to both internal logical files and external interface files. The group of data has to be visible to the user, okay? So it has to be accessible to the user via an input or an output. The group of data has to be logically related, okay? And has to be logically together, okay? That means that if certain data items are always associated, then they belong in a single group. So for example, contact information, right? So all the information related to the context is logically related. If you have, for example, the contact name, the contact phone, the contact email, the contact's Skype account. So all that information belongs together, okay? And therefore they are seen as an internal. They are seen as either an internal logical file or an external interface file, okay? Because the information belongs together. And something very important is we don't need to double count, okay? So before we count something as an internal logical file or an external interface file, we have to make sure it hasn't been counted before, okay? So don't count it twice. Now let's talk about the transaction functions, okay? Now that we have covered the data functions, we can talk about the transaction functions. All right, so the transactional functions. Just a second, please. Make sure this thing is recording. Yes, it is recording. Move the recorder over here. Okay. The transactional functions, again, we can have three different types of transaction functions. We can have external inputs. The external inputs bring information from the users into the application, and that information it's maintained in an internal logical file. Okay, so we could say that the purpose of an external input is to maintain an internal logical file. Okay, or bring control data into the application. An external output, it's presentation of data to the user. Okay. It's data that is taken from either an internal logical file or an external interface file, and it's presented to the user with calculations. So it's very important to clarify here that an external output involves calculations, involves transformation of the data, involves preparation of that data before it is presented to the user. Okay, so be clear on that, because that's the key difference between an external output and an external inquiry. An external inquiry, it's also a presentation of data to the user, but in this case, the data is not transformed, it's not processed, there are no calculations, there is no processing of the data. An external inquiry, it's a pure presentation of data to the user. That means we take the data, either from an internal logical file or an external interface file, and we present that data to the user as it is, without any transformations. That's the purpose of an external inquiry. Okay. So again, in SEER, you can classify the external inputs as either input screens, interactive inputs, hardware inputs, or batch stream inputs. Remember, this is purely a subclassification. It's not going to impact how we count it. It's not going to impact the weight it has on the estimate. It's just a better way of describing the internal input. Okay. You can do the same with external outputs. You can use these subcategories to classify the external output, and you can use these categories here to classify the external inquiries. Okay. So again, an external input is data that enters the application, right? So data enters the application and is stored persistently in an ILF. A good example of an input is changing a parameter in SEER. So when you change a parameter in SEER, you adjust the values for the parameter, and then you press the OK button, and that information, those parameter settings are stored in an internal logical file in SEER. Okay, so that's an example of an external input. Another example is the saving a new contact. So you collect information from the user, contact name, mobile phone, email address, and some more information. When you press the Save button, that information is stored in the contacts ILF. So add new contact, it's a transaction that brings information from the user into the application, and therefore it is classified as an external input. An external output, it's data that exits the application and it's presented to the user. And remember, it has calculations or processing. So a good example of an external output would be one of the charts in SEER that present, different results of the estimate. So for example, the effort sensitivity chart in SEER brings information from an internal logical file. There is some processing of the information in order to come up with, the sizes of these bars and the percentages and all that. So there are calculations involved, and then after those calculations are performed, the information is presented to the user. Another example of an external output is the report, the battery usage report in your Android device. So the battery usage data, it's stored somewhere inside your Android phone, and then when the user requests a report, a battery usage report, that information is retrieved from your smartphone. It's processed. It requires processing because it has to calculate these percentages here, and it has to calculate the bars here, the length of these bars. So there's processing involved in presenting this battery usage report to the user, and therefore it is classified as an external output. An external inquiry, it's presentation of data to the user, but in this case, the data is not transformed, the data is not processed. It's a straightforward fetch of information with no significant processing. So an example would be the little pop-up window from SEER SAM. So we're not talking about the chart here. The chart we already classified as an external output. We're talking about this small text box here with information. So when you move or set your mouse cursor here on one of these bars, you're going to get a little pop-up dialog here that tells you what the hours are, the effort, the schedule, and the cost. So that little pop-up here, it's classified as an external inquiry because it's purely a presentation of data. There are no calculations. So the hours, the effort, the schedule, and the cost are just presented to the user without any calculation. So that classifies as an external inquiry. Another example of an external inquiry is a report of your contacts information. So when you request from your smartphone a list of contacts, so that information is retrieved from the contacts data file inside your phone, and it's presented to the user without any calculations or any processing, just a list of the contacts. just to emphasize here the difference between inquiries and outputs, it's related to the processing. So as you can see, an output is something that takes data from inside the application. It performs calculations on that data. It probably creates additional data, or sometimes we call this derived data, and it presents that data to the user. Okay. On the other hand, the inquiry, it's just a pure retrieval of data. So the data is taken from inside the application and is presented to the user without any calculations or processing. Now, let's talk about function complexity. So we've talked about the two different types of functions we can have. We can have data functions and we can have transactional functions. Now, how do we classify those based on complexity? And to do that, I'm going to introduce some new concepts here, okay, that will help us classify the complexity of those applications. So the first concept I like to introduce is the concept of data groups. Data groups, we call them RETs, record element types. This is the standard name from IFBook, but for the purposes of function-based sizing, we're going to call them data groups. The other concept is data fields. Okay, we call them DETs, data element types. Right. So the number of fields is also used when rating complexity for data functions. So when you rate complexity for data functions, we're going to identify the data groups inside that inside those data functions, and also the number of fields. When rating complexity for a transactional function, we're going to use again the number of fields, the depths of that transaction, and then we're also going to count the number of data files used. Okay, so in other words, if a transaction presents information to the user, that information has to come from either an internal logical file or an external interface file inside the application. So how many files are touched by that transaction? That's the number of data files used, right? And we're going to be talking more in detail about each of these things. So again, data groups, it's the real name or the standard name from IFBook is a record element type. In a few words, a data group is a user recognizable subgroup of data elements within an ILF or an EIF or an EIF. So it's basically a subgroup of data. Data files used in IFBook vernacular, they are called FTRs or file types reference. Okay, and an FTR or a data file used is an ILF that is read or maintained by the application, by the transactional function, or an EIF that is referenced by a transactional function. So in a few words, data files used are the number of data files that are touched by a transaction, either an input or an output. How many data files are used in that input or in that output? And finally, data fields, in the IFBook vernacular, we call them data element types or DETs. And basically, a data field is a unique and user recognizable and non-repeated field of data. So let's start talking about data groups. So we could have a big database here that associates, different data from a catalog or kind of an inventory application. So inside that logical file. This could be either an internal logical file or an external interface file, and it holds orders. So this is the details of an orders database. So inside that orders database, you can have different subgroups of data. You can have employees, you can have orders, shippers, customers, suppliers, categories, products, and order details. So each of those subgroups of information are data groups, okay? So in this case, we count 8 data groups for this whole orders database that we're counting. So remember, the data groups, or REDs, as we call them, they not always equal to tables, but they often do. More on data groups. If you have a database that holds, information about teachers, information about instructors. So inside that data group, inside that data file, you can have a group of data that is related just to the instructor details, like instructor name, address, city, state, zip code, and telephone. So these are details about the instructor. But then you can have, inside the same database, you can have more information related to the courses that are taught by that instructor. So you can have instructor name, the name of the course, and the course number. Okay, so these are two separate groups of information, as you can see. Instructor, it's one data group, and courses taught, it's another data group. So again, data files used are simply the data functions that are maintained or referenced by the application. So how many data files are referenced by a particular transaction? Shouldn't say application here, it should say transaction. So it's the number of data files that are referenced or maintained by a specific transaction. More on data files used. Data files used. We covered this already. So data files used are the, again, the different files that are referenced or maintained by a transaction. So for example, when you're presenting information in a chart like this, that information has to come from somewhere, has to come from a file. Could be an external interface file or could be an internal logical file. But the data files used is just the number of files that are used to present this output, for example. And now the data fields. The data fields are basically unique, user-recognizable, and non-repeated fields. So for example, if you have an input that collects information about the font, okay? So the font type, the font style, the font size, the font effects, the font color, and the font script, all those are fields of information that are collected in this input. So all those are data fields that we count for this transaction. Here's another example of data fields. All right, so if you have a database that holds products, so each of these correspond to fields. So the product ID, the category, the product name, and the date. All those are data fields. Remember, the data fields can be used or are used when counting the transactions, but they are also used when counting the data functions. So the previous example here is it was an example of how we identify data fields in a transaction. So this is a transaction. We're going to specify the font. It's an input transaction, and these are the fields. Okay. This example here, it's basically a file. Okay, it's not a transaction anymore. It's a file, but inside a file, you can also have fields of information. Okay, so that's how we count the data fields. Let me go back a little bit here. So we've talked about three different concepts. We talk about data groups, okay, different groups of information inside a file. We talk about data files used, basically the number of data files that are used by a transaction. And then we talked about data fields. Data fields are the number of unique fields that are either stored in a file or presented in a transaction. So we talk about data groups, give a couple of examples. We talk about data files used, okay? They are simply the data functions maintained or referenced by the application. And then we finally talk about the data fields, what they are. All right, so now that we know the three concepts that are used to rate transactions and data functions, we're going to use these tables here to rate the complexity of the transactions. And these tables are going to be used to rate the complexity of the data functions. So here are the concepts that we previously described. So for inputs, we're going to use the number of data fields and data files used. Okay. So for example, if a particular input references or stores information in just one file, right? So we're going to use this column here, and then based on the number of data fields, we're going to classify that input transaction as either low complexity. If it has between 1 and 4 fields, it's also going to be low complexity if that input has between 5 and 15 fields. If it has more than 15 fields of information, it's going to be classified as an average input. If the input uses more than one data file, okay, well, in this case, 2 data files, not more than one, but 2 data files, we're going to use this row here. So if it uses 2 data files, but it has from 1 to 4 fields, it's going to be low. If it has from 5 to 15 fields, it's going to be average. And if it has more than 15 fields, it's going to be a high. And then we use this row here of the table if that particular input uses or maintains 3 or more data files. Okay, so that's how you read these tables. You first have to determine the number of data files used by that transaction, and then you classify based on the number of fields using the table here. For data functions, it works similarly. So you first identify the number of data groups inside that data function, and then you look at the number of fields. So if it has one data group only, and it has from 1 to 19, or even from 20 to 50 fields, it's going to be classified as a low complexity file. If it has between 2 and 5 data groups, we use this row here, and we classify according to the data fields. And the same for external files. These tables that you see here are here for reference, but you will also find them in the SEER help for function-based sizing. So my recommendation is that you print these tables and you have them handy when performing a function-based sizing count, because these tables are basically the summary of all the concepts that we have talked about, and you need these tables to classify your functions. Let's move on. There's another category of function-based sizing in SEER that we haven't talked about, internal functions. Basically, internal functions is functionality that doesn't classify as a data function, and it doesn't classify as a transaction. So it's not an input, it's not an output, it's not a query, and it's not an internal logical file or external interface file. It's just functionality that happens inside the application, and it doesn't send or receive any information to the outside world of the application. So it's data that happens internally to the application. These type of functions, internal functions, are very uncommon, okay? So they are very uncommon, especially for business applications, because usually in a business application, everything has to do with interaction with the user. So either information flows out to the user or flows into the application. But in case there is any functionality that happens internally to the application and doesn't result in any information being sent or received, that's classified as an internal function. And here are some examples. Signal processing, data reduction, data analysis, monitoring, data compression, encryption, in some application-specific calculations. So how do you rate the complexity of internal functions? The complexity rating for internal functions is not as mathematical as the complexity ratings that we saw for the data functions and the transaction functions. In this case, you rate the complexity more subjectively using these guidelines here. Like for example, an internal function is going to be low complexity if, for example, it's a simple routine, such as a sorting routine. Okay, so you sort information alphabetically or somewhere else. So a sorting routine, for example, will classify as a low complexity internal function. An average internal function, it's going to be, a reasonably complex function such as commercial data compression algorithms. And finally, a high internal function, it's going to be a reasonably complex function. There's a typo here. This is repeated. There's a mistake here. A high complexity internal function is something more like data encryption or those type of internal algorithms that have a lot of more processing involved. Okay. The reason why we don't cover internal functions a lot, again, is because they are very rare, they are very uncommon, and we don't expect you to be counting these, especially for business applications. These are more common to embedded applications and mission-critical applications. So don't worry too much about internal functions. Okay, and finally, how do you enter the function-based sizing inputs in SEER? And I'm going to demonstrate this using the tool. Let's open SEER for software. So in SEER, you're going to have a tab that is dedicated to your function-based sizing inputs. Okay, let's just create a new project. Let's open an existing project. So right here, when you see, let's see, lines of code, these are lines of code here. Oh, this is probably a good example. Yeah. Right here in SEER, you're going to have this function-based sizing tab. Inside that function-based sizing tab, you're going to have three categories. You're going to have new, pre-existing, not designed for reuse, and pre-existing designed for reuse. Inside each of those categories, you'll find the categories we've been talking about: external inputs, external outputs, external inquiries, external interface files, and internal logical files. And basically, once you have performed the count, you're going to come here and say how many external inputs you have, and how many of those are low, how many of those are average, and how many of those are high, based on the complexity complexity rating rules that we just described. Okay? If you expand each of these categories, you'll find the subcategories that we talk about. But remember, the subcategories are just an additional means of describing the transactions and the data storage functions. But anything you put, anything you put underneath external inputs, doesn't matter the category here, is going to have the same weight, and it's going to work exactly the same for the estimate. Okay, so don't be too concerned about the subcategory that you choose. You have to be really focused on getting the right category at this level. So classifying something as an EI, EO, EQ, EIF, or ILF. It's important. The subclassification at this level is not very important, at least for estimation purposes. It's more important for documentation purposes. So here is where you enter your function-based sizing inputs in SEER. Again, you have low, average, and high complexity based on the rules that we identified. And then you can do the same for your new functions. You know, if the functionality is being developed from scratch, you can do it for your pre-existing functionality, not designed for reuse. And you could also do it for your pre-existing functions designed for reuse. Okay, now let's take a look at how do we apply all these concepts in a real practical example. So here's our example. It's called the Workload Management System. Okay, so it's a system that maintains information about workload. So this is relevant. Is related to an organization, for example, that has employees, and a manager can come to this workload management system and assign tasks to different employees, okay, assign activities. So it's a very simple application that just helps the managers to assign activities to different employees. And obviously you can generate reports of the employees, reports of the activities. You can add new employees, add new assignments to that employee, edit the assignments, change an employee, remove an employee. Some of the things you can do in this application. So it's a relatively average application, and again, it's related to workload maintenance. So step number one, remember, is identify the application boundary. So the application boundary is basically an imaginary boundary that surrounds the application, okay, and it identifies what information is stored internally to the application and what information is stored externally to the application. So for our workload management system, we're going to have an internal data file that is called the workload profile. So this is where the activities are associated to the employees. So that's the workload profile. But the activities are not maintained by the application we're counting. The activities are maintained somewhere else. Maybe they use Microsoft Project or Project Server or something like that to develop the activities, okay? The application we're counting only deals with the workload profile or the assignment of those activities to the employees. So again, we place our boundary here. Now we know that we have a user, okay, which is the workload manager. We have an internal data file, that is the workload profile data file, and we have an external data file with the activities. Okay, so the next step is to identify the data functions and rate those data functions based on complexity. Okay, so the internal logical file in our example is the workload profile data file, and it's going to contain the following information. So this workload profile is going to contain the employee name, the employee address, the social security number, the employee skills, skill level, security clearance, employee location, current job activity, time spent on current activity, past projects, and time spent on past projects. So this is all the information that the file is going to store. So all these correspond to data fields. Remember the concept of data fields? It's each unique and user-recognizable field of information. So these are data fields, all right? Then the other concept that is important when counting data files is the concept of data groups. So in this case, we have a single data group with employee information. So we don't have any other data groups inside this file. So in other words, to count the complexity or to rate the complexity of this file, we're going to count one data group and 11 data fields. So we come again to our tables and we classify this file is going to have one data group. So we use this row, and it's going to have 11 data fields. That means that it classifies right here as a low complexity internal file. Okay, so the workload profile file, it's classified as low complexity. The other data file is the activities data file. Remember, this is an external data file because we said that the activities are maintained externally to the application. And we say that, you know, they could be maintained in Project Server or Microsoft Project, for example. But we have to count the file and we have to rate the complexity of the file. So in this case, the EIF, this activities file, it's going to have this information. It's going to have activity name, skill required, skill level required, security clearance required, location of the activity, and estimated time required. So these are, again, the fields of information stored in this file. And we cannot identify, or we do not identify, any additional data groups, right? So it's going to be just one single data group. That's something that I probably missed, but you never count 0 data groups. Any file is going to have at least one data group of data, of information. You never count 0 data groups, right? So a case like this, there are no additional data groups, but there's going to be always one data group, okay? So in this case, we count one data group and 6 fields of information. And again, what do? We come to our complexity tables, and in this case, we count this file has one data group, and it has 6 fields of information, so it classifies as low complexity file. So what do we do in SEER? So we just counted the data functions, okay? So now in SEER, we start by, let me create a new project. Let's call this the Workload Management System. Your name goes here, and then we're going to select K-bases. The selection of the K-bases is not in the scope of this training, so we're just going to assume we use these K-bases. business mission critical, MIF. We're going to say business mission critical, information systems, new, general, new and pre-existing, waterfall, and commercial. So these knowledge bases are selected based on the type of system that we're developing, but this is a given for this example. Again, we're teaching you here how to do function-based sizing, not how to do estimation in SEER. So we just take this as granted. So we create a new project. We're going to add our first program, Workload Management System, use the same K basis. Now we have this program. We're going to come here. We're going to assume that all the functionality in this example needs to be developed from scratch. So we come here under New Functions, and remember we have two files that we classified. One of them was the workload profile, which is an internal file, and the other one was the activities file, which is going to be an external file. I'm going to come here to internal files. I'm going to classify the workload profile as a database file, and we know it's low complexity. It's going to be the workload data. Okay, so it is already entered as a data function, and now I'm going to count an external interface file. Again, low complexity, and this is going to be the activities file. So we just counted and recorded in SEER the two data files that we identified in our example. Activities file is an external interface file, and then the workload profile is an internal logical file. Let's go back to our example here. Now the next step is, after counting the data functions, now we count the transactions. Okay, so the transactions again they are the either the inputs, outputs, or queries that move information in and out the application. So for the purposes of this example, we're going to assume that we have the ability to maintain employee information. Okay, so we're going to have a function to add a new employee. Okay, it's going to be an input screen, and we're also going to assume that we have a transaction to inquire about an employee. Okay, we're not going to work on the update an employee and delete an employee. Let's keep those out of the scope for time purposes. And then in terms of workload maintenance, we're going to have the ability to add a new job. Okay, so add a new job is going to be an input screen. We're not going to talk about update, time spent, and review job history again for simplicity purposes of this example. So the first thing we need to do is we need to understand each of those transactions, and we need to determine the number of data fields and the number of data files used. Okay, so for the employee maintenance, we're going to assume that there will be a unique input for each item on the internal logical file related to the employee. It's going to be a total of 7 fields, and we'll look at that in the next slide. For the workload maintenance input, we're going to assume that there will be a unique input data field for each item on the ILF related to the workload. Okay, so that's going to be 4 fields, plus 1 data field for the employee to identify the workload to be maintained. Okay, and then inputs will also come from the EIF, and we'll see this in more detail in the next slides. Okay, so each of these transactions is going to reference the workload profile okay? And in addition, the workload maintenance, it's also going to reference the activities database, right? So for the employee maintenance, it is better explained here. So we're going to add a new employee. So when we add a new employee, the user is going to be presented with a screen, and in that screen, he's going to enter the employee name, the employee address, the employee's social security number, employee skills, skill level, employee security clearance, and employee information. So those are the fields that are going to be presented to the user when adding a new employee. In those fields, that information is going to be stored in the workload profile, okay? So how do we count this transaction? We count this transaction as using one data file, again, because all the information is going to be stored in a single data file, and 7 data fields. The complexity is going to be low. We'll look at the tables in a second. But this is how we count this transaction, based on the number of fields and the number of data files that are used in this transaction. Now, when we look at the other transaction, the workload maintenance, this one is a little more complex. Why? Because it involves 2 data files. So when you're adding a new job, so you're going to add it's a new job assignment. Sorry, it's not a new job, it's a new job assignment. So you're going to add the employee name, the employee skills, employee skill level, employee security clearance, and employee location, okay? So that information is going to be part of this transaction. And you're also going to specify the activity that employee is assigned to, the skill level, the skill level required, security clearance required, the location of the activity, and the estimated time required. So in other words, when the user wants to add a new job assignment, he's going to be presented with a screen, and he has to specify all of these things, okay? Now, in this case, some of the information it's going to come from the activities database, right? And then the other information it's going to come or is going to be stored in the workload profile, okay? So notice that we need to reference the activities data file in this case because we need information about the activities. Okay, so we need information about the skill level required for the activity, the skill required, the security clearance required, the location of the activity, and the estimated time required. That information is going to be stored as part of this transaction, but that information resides in the activities data file. Okay, so we're having to reference 2 files here: the workload profile, where the information is going to be stored, and then also the activities file to get all these details. Okay, so this is a transaction that references 2 files and a total of 11 data groups. So how do we classify our transactions? Again, we classify the employee maintenance has 1 file and 7 data fields, so we classify it as a low complexity. And the workload maintenance, remember, it has 2 files that are being referenced and 11 data fields. So this one is going to classify as an average complexity input. Okay. Just a second here, please. And we're still recording. Okay. Okay, so this is very clear. Okay, so what do we do in SEER now? We're going to go back to our estimating SEER under external inputs, and we're going to count one low complexity for the employee maintenance and 1 average complexity for the workload maintenance. And as you can see, as I specify inputs in my estimate here, I already see an estimate being generated. So let me get back here for a second so that I clarify something for you. Okay, so something I like to clarify is with regards to the workload profile. As you can see, there are some details here that are related to the activity, okay? But there are other details that are related to, to the employee. So there are some details related to the employee, but there are also some details of the activities, okay? So when we add a new employee, here, we're only going to write to those fields related to the employee. Okay, so that's why we only reference one data file. However, when we're adding a new workload or job assignment, we're going to be adding fields related to the employee and also fields related to the activity. Okay. Okay. But the fields related to the activity are going to be retrieved from the activities database. Okay. So that's why we have to reference the activities. So 2 files that are being referenced in 11 data, not data groups, but data fields. Okay. Now let's talk about the outputs of this system. So imagine that the users need to be able to do the following. So we need to be able to generate a report with the specific employees information, with the total hours spent on each activity. We need another report with the hours spent on a specific activity, and we need another report with all employees who meet the criteria for a new job. So we're going to need 3 reports. And now the next step in order to count these outputs, okay, it's to determine the number of data fields and data files used associated with each of these outputs. So the first report is the employee's information, okay? So the employee information report is going to list 11 fields of information from the workload profile, okay? So it's going to be 11 fields and 1 file used, just the workload profile. The report of hours spent on a specific activity, this is our second report here, would list the employee name, the current activity, and the time spent on that current activity. So it's going to have 3 fields of information, and it's only going to reference 1 file. And finally, the third report that we need is the employees who meet the criteria, okay? So that report is going to list all the 6 stats from the activities database plus the employee name from the workload profile. So it's going to be a total of 7 fields and 2 files being used because we need information from the activities database and also from the workload profile. So more in detail here, the first report or the first output is the employee information report. So this is going to be an output report that's presented to the user, and again, it's going to list these 11 fields related to employee information, and the information is going to come only from the workload profile. So we count this external output as having 1 file used and 11 data fields. The second report is the time spent on each job. It's a report with total time on each job. And this report is going to be very simple. It's only going to list the employee name, the current activity assigned, and the time spent on current activity. This third one here is calculated. Okay, so this is data that has to be calculated before it is placed on the report. So in this case, this makes the difference, remember, between an external output and an external inquiry. So this total time on each job report is essentially going to be an external output, and it's going to have 3 data fields of information and 1 file used, in this case, the workload profile. And finally, the list of employees with skills for a job, or the employee qualification report, is going to list the employees that meet the criteria for a specific activity. So this report is going to list some fields, okay, it's going to list some fields that need to be retrieved from the activities data file. And it's also going to list fields, in this case, just the employee name from the workload profile. So as you can see, here's an example of another report or another transaction that needs to reference data from 2 different files. So some of the information on the report is going to come from the activities, and some of the information in that report is going to come from the workload profile. So in this case, we count 2 files used and a total of 7 data fields for these transactions. And how do we grade those transactions? Well, the employee report, we said it was going to have 1 file used and 11 data fields. So that one counts as low complexity. The job activity report is going to reference 1 file and it's going to have 3 data fields. So that's going to count as low complexity again. I'm sorry, here, low complexity. Okay. This red circle here actually corresponds to the employee report because it has one data file used and it has 11 data fields. So that one is here. The job activity report is this one. It doesn't matter, they are both low complexity. The employee qualification report is going to have 2 data files used. Okay, we use this row, and it's going to have 7 data fields. So we fall right here, 2 data groups between 6 and 19 data fields. So it's going to be an average complexity. So what do we do next? Go to SEER and enter our reports. We're going to classify all of them as screen reports. So we're going to have 2 low complexity and 1 average complexity. And they're going to be the employee information report, the job activity report, and the other one was the employee qualification report. Okay. Okay, and finally, we're close from to finish now. We're going to be talking about the inquiries. So we already identified some inputs, some outputs, and now some inquiries for this system. So the first inquiry is going to be inquiry about an employee, and the other is going to be review job history. Okay. So with regards to the inquiry about an employee, so let's assume that we're gonna need two inputs for this inquiry. Okay. So the employee name and the social security number. So this inquiry is going to consist of first a screen where the user can enter a specific employee name and social security number, and in response, the system is going to display the other 9 fields of information in the workload profile ILF that are related to employee. So we have a total of 11 data fields. Something very important here that I like to clarify is an inquiry is not purely is not all the times just information presented to the user. Sometimes there is information that the user specifies to the application, and the application responds back with more information. Okay, so like in this case, the user specifies employee name and social security number, and the application responds with 9 other fields related to the employee. So we count a total of 11 data fields. We count both the input fields and also the output fields. And then for the review job history report or inquiry, we're going to assume that there's going to be one input. You specify the job name, and in return, the system is going to display the other 5 items in the activity database. Okay, so it's going to be a total of 6 fields. Let's look at this in more detail here. So information about inquiry about an employee. So remember, the user is going to specify these two in an input screen. So the user comes and says, okay, employee name is this, and employee social security number is this. So these are the 2 fields that are the input side of the inquiry, and then the application is going to respond with all the details. So the application is going to present address, skills, skill level, clearance, location, current activity, time spent on current activity, past projects, and time spent on past projects. So we count a total of 11 data fields for this transaction. And again, all the information is coming from a single source, a single data file. So we count this as having 1 file use and 11 data fields, 2 input data fields and 9 output data fields. In the case of the job history inquiry, remember, the user is going to specify an activity or job name. It's going to be the input, and then the system is going to respond with the skill level required, security clearance required, location of the activity, and estimated time required. So a total of 6 fields of information, and all the information is going to be coming from a single source, in this case, the activities data file. So we come to our complexity tables, and we classify both of them as low complexity. They both have 1 file use, and they both have between 11 and 6 data fields. So they both classify as low complexity. So we go back to SEER. We come to the inquiries. We're going to classify this as request response, because again, the user is requesting something and the system is responding with more information. Both of them are going to be low complexity. So employee inquiry and job inquiry. Should be 2 actually. Okay. And now the next steps, which are actually kind of out of the scope here, is we already have an estimate in SEER. Now, once you have specified your size inputs here, you can come to SEER and you can fine-tune your estimate by specifying more detailed parameters, okay? So the example talks about, you know, system integration in this case. So we want to fine-tune our estimate based on the number of systems that are integrating. So let's assume that our workload profile management system has to interface with at least 2 and probably no more than 4 applications. So we're going to go here under system integration, and we're going to say that we're going to have to interface with 2, likely 3, and no more than 4 applications. So this is other applications we need to interface with. And then the development of this workload management profile is going to involve 3 geographical locations: US, India, and Costa Rica. So we come here to multiple site development, and we're going to raise the complexity to very high to indicate 3 geographical locations. Can specify some range around the input, but it's essentially going to be 3 geographical locations. And as you can see, we have an estimate now. It's looking at 488 hours of development in 3.36 months of the schedule. And these inputs are based on the function-based sizing we specified. Okay. And that concludes our function-based sizing example. Thank you very much for your time.